Okay, students, sorry for the delay, slight delay. Now we will start our topic. That was the previous slide from the yesterday's class. Now we will begin with the current topic. First of all, we will recall some concepts. I hope you have remembered everything. Again, you have to choose the correct statements out of these. Okay, so you can answer me in the chat box how many these statements are correct. The first statement says work done against the conservative force is stored in the form of potential energy. First statement is the actual definition of potential energy. Work done against the conservative force is stored in the form of potential energy. The first statement is true. Now, I will come back to the second statement later in a few minutes. Now, coming back to the C, potential energy is defined for a system. Is this the clear-cut statement that I have told you yesterday that potential energy is always defined for a system? So this is again true. Now third relation is in the relation U is equals to mgh. Can you tell me what is this U is equals to mgh? This is the potential energy, gravitational potential energy basically. So this gravitational potential energy is mgh. So they are saying that h is the height of the body from the reference level. Now, from here we left actually. What I am saying that I am not saying, the statement is saying that if this is our ground and this is our ball M, height is h, then its potential energy is mgh, where h is what? H is the height from the ground. H is the height from the ground. This ground can be considered as reference point. This ground can be considered as reference point or reference level. Are you getting these things? This reference level means at this point, potential energy will be zero. What is the meaning of this reference level? That at reference level, potential energy is considered to be zero. So make your mind about these things, that the reference level may be anywhere, and at the reference level, potential energy can be assumed zero. This is our choice. This is our choice. If in a problem, we can decide the reference level at any other point, that totally depends on the questions. So what is this h? H is the height of the body from the reference level. So statement D is also true. Now coming back to the second statement. This is again a very good statement. Now have a look at that. Just listen to the board very carefully. I will change the color. Have a look. Now, let's take, this is our ground. This is our ground. And a ball is moving from point A towards point B. Ball is moving from point A towards point B. And who is moving it? I am taking it. I am taking it from point A to point B. If you can see, if I am taking it from point A to B, like that, A to B, where I need to apply the force, in which direction I need to apply the force? I need to apply the force in the upward direction. No? Only then it will go upward. Am I clear to you? If I need to put the ball from A to B, then what I need to do, I need to apply the force in the upward direction. So force applied by me means external person. I am the external person now. So force applied by me is in the upward direction and displacement is also in the upward direction. So work done will be positive. And this work done is stored in the form of potential energy. Keep everything in mind. This work done will store in the form of potential energy, or in other words, I will say that this work will increase the potential energy of the system. This work done will increase the potential energy of the system. This is the most important point that I am saying. Now, think otherwise. Think otherwise what I am saying. Consider the same ball again moving from A to B. What if I say that gravitational force is acting in the downward direction? Is it correct now? Gravitational force is acting in the downward direction. And the ball is moving in the upward direction. So the work done will be negative in this case now. Work done will be negative in this case. What I have told you, work done by the external agent is equals to change in potential energy. Now, can you see that ball is again moving from A to B? Displacement is same. Forces of external agent and gravitational force must be same. Only in that case, no acceleration will be produced. So that means both the work done are same. But work done by external agent is positive and work done by gravity is negative. Gravity is what? Conservative force. So here we can conclude that work done by conservative force is equals to negative of potential energy. This negative sign is coming from where? Coming from these two terms. These two forces are equal in magnitude but opposite in sign. So this minus sign is coming from the negative sign of this negative sign. So again, this is true. So all four statements are true, and these four statements need to be put on your notebook very carefully, very precisely, because these are the crux of the previous lectures. You need to remember these statements. This is the most important relation. Now, moving further with have you remembered the equation of conservation of mechanical energy? Anyone who remembers the equation of conservation of mechanical energy? Just say yes or no. Still waiting. You can write it in the chat box quickly. Quickly, 1, 2, 3, 4. Quick. Nobody remembers. You can also write no if you don't remember. Okay, moving ahead. So here are few questions that we are going to discuss, and this is a very good concept building questions. Read the question. Question says there is a ball of mass m at a height h above the ground, and it is then released What are they saying? Find the kinetic energy of the ball when it reaches the height h by 2 above the ground. H by 2 above the ground, that means it should reach here now. And this height is h by 2. I know some of you can calculate this energy using work energy theorem. That's the easiest way to solve that. But in this particular topic, I am going to teach you how to use conservation of mechanical energy theorem. How do we use that? So let me show you first. What we need to do, we need to calculate the kinetic energy at this point. Suppose this point is A and this point is B. Can you say that ball was initially at A and finally, when we want to calculate the kinetic energy, it is at B. So this is our initial condition and this is our final condition. So that's what I am saying. You need to identify your initial and final conditions. First thing. Now, second thing. What I have told you, mechanical energy initial is equals to mechanical energy final. Because there is no non-conservative force present. So mechanical energy initial is kinetic energy plus potential energy is equals to kinetic energy final plus potential energy final. What you need to do next step, you need to decide your reference level. You need to decide your reference level. In this question, I am deciding the reference level as ground. At the reference level, what happens? At the reference level, potential energy is zero. What is the meaning of reference level? At reference level, potential energy is zero. If somewhere at some point u equals to zero is written, that means that is your reference level. Okay. So kinetic energy initial, that means kinetic energy at A. From A it is released. Released means it was just dropped. So it has zero velocity. Zero velocity, that means kinetic energy initial is zero. Plus potential energy initial at point A, potential energy will be, from where will you calculate the potential energy? From the reference level. And from the reference level, height is mgh. mgh is equals to final kinetic energy we want to calculate plus final potential energy. Finally, ball is at B. The height of B from the reference level is h by 2. So that will be mg h by 2. So K final is, can you transfer it? It will become mgh by 2. This is what? This is our final kinetic energy. If they have asked you the final velocity at B, then you can easily put kinetic energy as half mv square and you will calculate the velocity v. So is it clear to you? This is the basic term. You need to remember the steps actually. First of all, you need to identify the initial and final position. After that, you need to define your reference level for the calculation of potential energy and then apply conservation of mechanical energy. Keep in mind, there should not be a non-conservative force in the system. Only then you can apply. JNV Mahe says nice class. Thank you, JNV Mahe. Okay, so moving ahead, I have another question for you. Okay, so I am going to give you a question here. Let's create a question that will help you. Have a look at that. Let's suppose this is a table. I am not a very good in drawing. Let's suppose this is a table and table is smooth. If this is the table, then this must be the ground, and a block of mass m is moving with a velocity u towards this spring, which has a spring constant k, What you need to do, you need to find the maximum compression in the spring. Again, someone may say that it can be done using work energy theorem. I will say yes, definitely it can be done. But what I am trying to do, I am trying to uh, build the concept how to use conservation of mechanical energy. Then there will be some questions. Some questions are easier to solve using work energy theorem. Some are easier to solve using conservation of mechanical energy theorem. It totally depends. So you need to clear both the concepts now. Okay. So the question says, let, again, I'm saying, let this height is h. H is the height of the table. And you need to find the maximum compression in the spring. The question is clear to you now. Is there any doubt in the question? After that, I will start. I'm repeating it again that you need to be proactive. You need to be active. You need to write down everything so that you can create a link with me because it's a online teaching means you have to create a link by answering in the chat box. Okay. So I hope the question is clear to you now. Moving towards the solution. What I have told you that you need to identify the initial and final position. If I say that I need to redraw the diagram now. This is your table. Can you say that if block will strike the spring, it will compress the spring somewhat? Actually, it looks like that block is also suppressed, but it's not. It's a drawing fault actually. Block is not that much compressed actually. Let's say the compression in the spring is X. And the compression is created by this moving block. At the maximum compression, the velocity of the block will be zero. So what I am going to say, identify the initial and final situations. So can you say that this is our initial condition and this is our final condition? And we need to apply the conservation of mechanical energy theorem. What does it say? I hope you have remembered everything. Ki plus Ui is equals to K final plus U final. Is it clear? Now let me clear one thing, that potential energy is defined for a system. Potential energy is defined for a system. And in the case of spring, I have told you that system is what? Spring plus block is a combined system, is a part of the system. So what is our system? Spring plus block. This is our system. Now again, this is again a very conceptual term. Next step is to identify the ground level. Some of you might say that we will choose this is ground. You can easily choose it as a ground. But what if I am saying that choose this point as a ground? Because I have told you, you can choose any position, any location as your ground position, as your reference level. So if I choose this position as a reference level, the block has zero potential energy. Do you agree with me? Because it's on the ground. If I choose reference level at this point, then block has a height h and it will have a potential energy mgh. Clear? So it will not depend on that. So answer will not depend on any of these things. Answer will depend on your applications. So I am choosing reference level at this position. So I am writing kinetic energy. Kinetic energy is what? Half m u square. Done. Plus potential energy. Whenever you need to put potential energy, you need to put potential energy of every part of the system. You need to put potential energy of a spring, potential energy of block, everything. There may be number of bodies present in the system. So here there are two bodies. So can you say that potential energy of block is zero? Because it is on the ground that we have chosen. Plus potential energy of spring is what? Half k x square. But if I am writing the initial potential energy, then initially the spring is not compressed. Spring is not compressed, that means x is equals to 0. So initial potential energy is also 0. Now, final kinetic energy, block will come to rest. So final kinetic energy is 0. Plus final potential energy, if I write, I will write potential energy of what? Potential energy of block and potential energy of spring. Potential energy of block is again at the ground level. Na? So potential energy of block is 0 plus potential energy of spring is half kx square. If you can see that, it will become half mu square is equals to half kx square. We need to find the maximum compression. Half cancelled out. X square is equals to m by k u square. X is equals to root m by k u. Some students can remember this result because this is a basic fundamental result and can be used in various questions. Now, tell me one thing, is the concept of application of mechanical energy, conservation of mechanical energy clear to you? Can I increase the level of the question? Can I? Okay, I am increasing the level of the question now. Okay, let's do another question. Again, have a look at that. This is our ground. And there is a spring. It has a platform over it. Okay. A spring has a constant K. A ball of mass M is dropped from the height h of the platform. Is this thing clear to you? What's mentioned in the question is a spring is placed vertically, which has a spring constant K. A ball of mass M is just dropped from a height h as shown. What you need to do, you need to find the maximum compression in the spring. Try to make some idea in your mind. Try to make the finalized diagram. What will be the final diagram? How it will look? Only then you will be able to solve the questions. Huh? And after repeating various times, nobody is answering that is it clear to him or not? Is it okay? My voice is clear to you? Any sort of questions you need to answer in the chat box. So I am drawing the final diagram. Okay, can you imagine that when this ball will hit the top of the spring, this platform attached to the spring, this will compress. It will compress now. So it will look something like that. Finally, it will look like that. This is M. A spring constant is K. So how much it has compressed? It has compressed by a distance, suppose that X. And we need to calculate this X. Is it clear that what we are going to do now? Again, let's mention the initial and final system. So this is our initial system I. This is our final system F. And we will write the conservation of mechanical energy. What does it say? Kinetic energy initial plus potential energy initial is equals to, this is Ki plus Ui is what? Mechanical energy initial is equals to kinetic energy final plus potential energy final. Now, who is the part of the system? Spring plus block. Who is the part of the system? Spring plus block. These are the part of the system. Now, if these are the part of the system, we will write the energies for both of them. As the mass of the spring is massless, so we will not write the kinetic energy of the spring. That's what you need to understand, because it has no mass. Ideally, we have taken the ideal spring. So again, now next step is to identify the position of reference level. So this is up to you. You can decide whatever you want. Now, I am giving you few options and you need to pick one. The few options that you have, one is you can choose ground at A. Another is you can choose ground at B. And third one is you can choose ground at C. So you can choose anywhere you want. Can anyone has any choice of choosing this? And then I will tell you that which is going to be a good choice. Okay, someone is saying A. JNV Mahe is saying A. Okay. Okay, in that case, JNV Mahe, if you choose A, that's a very good question. Actually, that's a good point that we have raised here. If you choose A, then, and if I ask you to write the potential energy of this ball, Then what is the height of this ball M? What is the height of this ball from the ground? You know this height, na H, but you don't know the length of the spring. Are you getting my point? You don't know the length of the spring. So you will not be able to write the potential energy of the ball at this position, at this initial condition. For that, you need to mention, you need to take a variable. You need to take a variable. Suppose you need to take L as the length of the spring. Only then you can write potential energy. That will be mgh plus L. Okay. Few of you, JNB, it's very difficult. Yavatmal is saying that A is the choice. Okay. So now, if you say A is your choice, then do you get the difficulty in choosing A as the reference point? I hope you will get the difficulties here. So for that, you need to mention the length of the spring now, and which is not given. So why we should do such work that is going to increase our task, that is going to panic our work. So if I choose B as the reference point, I'm giving you the choice. If we choose B as the reference point, then do you know the height of this ball from B? Yes, you know. It is X plus H. You can easily calculate that. X is what we need to calculate. So choosing B will be a good option. Choosing B as the reference point is good option. So whoever the person replied with A, is it clear to you that A is not a good choice? I am not saying that you cannot solve the question by choosing A as the reference point. No, you can solve it by choosing A as the reference point. But which is better for us? Choosing B or choosing C? Both the choices are better. Again, C is, I am not choosing C because of two reasons. Because for C, you need to write potential energy of this ball from H height and again at a depth of X. But if you choose B as the reference point, you have selected this position as zero potential energy, so you don't need to write the potential energy here. I think these things are not getting messed up in your mind. You are connected with it. So I have chosen the reference level. Kinetic energy I am writing. Initially ball is at rest, so kinetic energy is zero. Plus potential energy of the spring. So the potential energy of the block is mg h plus x. Is it clear? This is the potential energy initially is equals to kinetic energy final. Again, the maximum compression means potential kinetic energy is zero plus potential energy. Again, I will write potential energy of this ball zero, of the spring half kx square. So it will become mgh plus mgx is equals to half kx square. Can you see that this is going to be a quadratic equation? Can you see that? This is going to be a quadratic equation now. So if it is a quadratic equation, you can write it in terms of x. X square is equals to, if I transfer this 2 and k here, so it will become 2 mg by k h plus 2 mg by k x. This is the quadratic equation. If you solve this quadratic equation, you will get x. And this is your task to calculate x from the quadratic equation. I think these things are again very much clear to you. Now we have clarified the concept of mechanical energy application. Now moving ahead. These are the basic questions that you need to know. Now we are increasing the level again. Is it clear to you now? Please say it yes or no, whatever it may be, you can tell me. Moving further. Find the kinetic energy. Yes, sir. JNV Mahi says yes, sir. Things are clear to him. Okay. Again, find the kinetic energy of the ball when it makes an angle theta with the vertical. I think 4:30 is the time. We need to hurry up for this question. Question says, let me explain the question to you and you will do it in the homework. Question says, the ball of mass m is suspended by a thread of length L. Is this thing clear to you? After that, the ball is given a velocity u, a horizontal velocity u at this point. At this point, at the lowermost point, it is given a horizontal velocity u. You need to find the kinetic. Acha, whenever we give some velocity at the lowermost point, this ball will go like that. Now. So we need to find the kinetic energy of the ball when it makes an angle theta with the vertical. That means at this point, we need to find the kinetic energy of the ball. So let's suppose this point is A and this point is B. This point is A, this point is B. Using conservation of mechanical energy theorem, can you say that this is our initial position and this is our final position? Initial and final are clear to you now. So again, I am writing K initial plus U initial is equals to K final plus U final. Now again, you have to decide your reference level. I am choosing this position as reference level. And this is a pro tip to you, either at initial position or at final position. Choose your reference level only at these two locations, either at initial position or at final position, because it will create a zero term for you. Because after choosing u equals to 0 at this point, what I got potential energy at this position 0. So it will be easier for me to solve the questions. Less number of terms are there, na? Because one term becomes 0. So, okay. Writing K initial. K initial is what? Half m u square. Clear? And u initial is what? 0. Because the ball is at the ground itself, at the reference level itself. Now equals to K final. K final is what you need to calculate. You need to calculate the kinetic energy at B. Plus U final is what? U final is what? M, G, and what is the height? So what is the height? Can you say? This is the height H in the diagram. You need to calculate this height. This is our purpose. That's what we need to calculate. If we calculate the height H, then our question is sorted. So now, half m u square is equals to K final plus mg and H we need to calculate. So come here. Come here. Let this point is P, Q, R. In triangle PQR, can you see that PR is the base? PR is the base. PR is the, and this PQ is the hypotenuse. And this PQ is L, na? Because length of the string is L. So base is what? Base is what? Base is hypotenuse into cos theta. Hypotenuse is L into cos theta. PR is L cos theta. If PR is L cos theta, the complete length is L. So the H will, what will be the value of H? L minus L cos theta. You can take L as common, 1 minus cos theta. This is what H. Put the value of H, L 1 minus cos theta. So you will get the answer K final is equals to half mu square minus mg L 1 minus cos theta. This is your answer. Now, I have an information for you actually that you need to know. The information is on 18th of December, there is a JE test that is called as, I think the name of the test is, let me clear, All India Enable Test. On the 18th of December, there is a All India Enable Test, AIET, that you need to participate. Every one of you need to participate in that test. That will give you knowledge, that will give you the information about your knowledge, about your concepts, how strong you are, that much knowledge you have. So please attend that test, and it will help you a lot. And we will discuss that test in the later section. I hope everything is clear to you. So it's time to leave. Thank you, everyone. Thank you, everyone. Thank you. Thank you, JNV Mahe.